Okay, I got it. I'm gonna teach. Okay, a circle, which I'm sure you're familiar with, looks like this. It is a set or group of points in a plane that are equidistant, however you'd like to say it. Like that. I'll zoom in. Equidistant from a given point called the center of the circle. So a circle can you not talk? A circle by definition is all the points equidistant from this center. A circle is named by its center. And the symbol for circle looks like this. So you could say circle A. So circle A or circle A. Okay, radius is another word that you are familiar with. It's the distance from the center to the outside of the circle right here. If you're talking about more than one radius, it is called a radii. A line segment from the center of the circle to a point on the circle. A radius is a segment, so to name, you use a symbol for segment. Okay, and a chord. This is a new word for you probably. A chord is a line segment with both endpoints on the circle. So here is a chord here. A chord doesn't have to be through the center like diameter does. Then we have diameter. Diameter is a chord that passes through the center of the circle. It's made up of two radii, and a diameter is a segment, so to name, you use the symbol for segment. And you've seen diameter before. It's all the way across through the center. To find the length of the diameter, sometimes you do have to multiply the radius by 2, because radius is half of the diameter. And then we have these concept questions right here. It says, think about it. Are all circles the same size? No. Sometimes there's small circles and sometimes there's large circles. What determines the size of a circle? The radius.
Yes, all circles are the same shape.
Are all circles the same shape? That is yes. Some are small, some are big, but they're all the same shape, meaning they're all similar. And moving on to the next page. All circles are the same shape, but not the same size. As we just mentioned. Therefore, all circles are not congruent, but they are similar. Okay, here's a couple key concepts. Circle pairs. Two circles are congruent if and only if they have congruent radii. So if the radii are the same length, then those circles are congruent, meaning their area would be the same, circumference would be the same, all of that. Then here is another concept. Concentric circles are coplanar circles that have the same center. So here you have a circle that lays inside the other circle, and they're concentric, meaning that their center is the same. Okay, moving down here. Now this is laying the foundation for some of the other concepts in the chapter. Two circles can intersect in two different ways. They can intersect at 2 points, and that would look like this. If you have two circles, they don't have to be the same size, but they intersect. They're supposed to be circles. Mine looks like an oval, but that's just human error. These intersect at 2 points. And then circles can also intersect at 1 point, and what that would look like is if you have two circles that intersect at 1 point. Or they could not intersect at all in the case of concentric circles or just two circles that don't intersect. Okay, so here we have an example of a problem where you have two circles that do intersect at 2 points. Here it says the diameter of circle S, so here is the diameter of circle S is 30 units. The diameter of circle R is 20, however, we aren't going to use that in this problem, so I'm not going to label it because it's going to get very crowded. And then DS is 9 units. So this length right here is 9 units. It says find the length of CD. So just this segment right here. Okay, so it says the entire diameter of circle S is 30. This segment right here is 9 units. What's the length of this little segment here?
Half of it for 15.
No, it's
Minus 9.
okay. So to find the radius of circle S, you would divide 30 by 2 to get 15. And then this length is 15, so you could do 15 minus 9 to get 6. So CD equals 6.
Why did you say done?
Because you're confusing me.
It was good.
Yes. So you have to look at what you have and then figure out whatever they're looking for. Okay, so that was 2 pages. We just have one more page. This is going pretty quickly. Okay, so here's some more vocabulary. Some of this you've seen before. Circumference you've definitely seen before. It's the distance around the circle. So it shows you a picture right here. It's the distance around, like the perimeter of a circle. There is a formula to find circumference. Circumference equals pi times diameter. The reason why it has or this equation here is because sometimes they don't give you diameter, they give you radius. If they give you radius, you have to multiply the radius by 2 to get the diameter. So sometimes the equation looks like this, 2 pi r, if you are given radius. Okay, and then pi. Pi is a ratio of circumference over diameter. You may recall when we did that pumpkin project, you took the circumference of the pumpkin, divided it by the diameter, and you got pi, which is 3.14. Also, if you forget this ratio here, circumference equals pi times diameter, you could just solve for pi. So if you divide both sides by diameter, then pi equals circumference over diameter. Also, pi is 3.14. Conceptually, it does make sense. The circumference of a circle does seem like it'd be 3 times that of the diameter. Just visually, it does look like it's about 3 times the length. Okay, so here's some new words. Inscribed. A polygon is inscribed in a circle if all of its vertices lie on the circle. So here, the triangle is inscribed in the circle. And then circumscribed is when it's the outside. So in this case, a circle is circumscribed about a polygon if it contains all the vertices of the polygons. The circumscribed polygon is a polygon outside or around. So inscribed is inside. It's when the shape is inside. Circumscribed is when it's outside. So in this example, the circle is the circumscribed one. Okay, and now we're going to look at some math and how it might be incorporated in math problems. The instructions say find the exact circumference of each circle using the given inscribed or circumscribed polygon. Exact means you should leave your answers in terms of pi, so for these we'll leave it in terms of pi, and use radicals when necessary. Apply your knowledge of Pythagorean theorem and special right triangles to find missing measures. Okay, so for number 1, they want to find the circumference of this circle. Well, in order to find circumference, we need diameter, because circumference equals pi times diameter. We're going to use Pythagorean theorem to find that diameter. So this would be our A and B. And then this would be C, but I don't want to confuse it with circumference, so we'll call it just diameter. So 8 squared plus 6 squared equals diameter squared. C. It is 10. 100 equals d squared. Take the square root of both sides, and diameter equals 10. You don't need a calculator, actually. It says to leave your answer in terms of pi. So for this, circumference equals pi times 10. So circumference equals 10 pi. So this is a good example of what they might put on like a non-calculator portion of the test, because you could do it in your head. Okay, number 2, same type of problem. This time they show you that you have an isosceles right triangle. If this is 9 inches, so is this. With an isosceles right triangle, it is a 45, 45, 90 degree triangle. So I'm going to actually draw out. Remember the special right triangle that was 45, 45, 90? These two were the same measure, and then the hypotenuse was x times square root of 2. So in this case, it's going to be 9 square root of 2 is the length of the diameter. So circumference equals pi times diameter. Circumference equals pi times 9 square root of 2. And we're leaving it in terms of pi, and it says to leave the radicals. So our answer is 9 square root of 2 pi. And that's it.
I'm sorry to interrupt, but apparently the answers are on here too.
Correct, yes. And if, whatever reason, the multiple choice answers were in decimal format, you could just solve this out in a calculator to get the decimal. Number 3, now this time the circle is inscribed. It's on the inside of the square. So we're still trying to find the circumference of it though. It says that this length is 11, so therefore the diameter is 11. Circumference equals pi times diameter. So circumference is pi times 11. We're leaving it in terms of pi, so our answer is just 11 pi. And there is one more type of example I want to go over in case you get it on the homework. What if they say, okay, circumference equals 20 pi. What is the radius of the circle? You could use the equation for circumference backwards. So you could say if circumference equals pi times diameter, then 20 pi equals pi times diameter. And work it backwards to solve. So you could divide both sides by pi. These would cancel. And you're left with 20 equals diameter. So the radius would equal half of that, which is 10. And that's how you'd solve something like that. You work backwards. And that's about it. The homework is actually easier than this, which you'll be happy about. If you have questions with the homework, let me know. When you finish the homework early, not if. When you finish it early, get started on Khan Academy for the week. It's all on this stuff. So if you have questions, let me know. And I'm going to stop recording.